Welcome to qnawire.
In this problem, we've defined the velocity of a rock being whirled around a circle in two different scenarios. The first scenario has the circle that it's being whirled in horizontal, parallel to the ground. And the second scenario is vertical. So let's start by drawing free body diagrams for our two scenarios. In our first case, in which we have a ball here, attached by some string parallel to the ground, there are two forces acting on our ball. First, there is the force pointing downward, Fg, and then there is the force pointing towards the center of the circle, the tension. In this case, there's only one force that is pointing towards the center of our circular motion, and therefore that must be the only force responsible for our centripetal force, T. That means that we can write that T is equal to mv squared over r, our equation for the centripetal force. Fg doesn't contribute because it's pointing straight downwards. Now, our second scenario is a little more complicated. We're going to look at two specific points. Point 1, the bottom of the circle, and 2, the top of our vertical circle. Now, at point 1, right, we have a force pointing downward, Fg, and a force pointing upward towards the center of the circle, T. So that means that in this case, the centripetal force must be equal to the difference between these two. It's T minus Fg. The second point, the top of the circle, our two forces are pointing in the same direction. We have T towards the center of the circle and Fg as well, downward toward the ground. So Fc equals T plus Fg. Now, this problem tells us that the velocity, or rather the tension that the vertical ball experiences at its maximum tension is 15% larger than the tension anywhere for the horizontal circle. And so where's the tension in scenario 2 at a maximum? Well, based on the two scenarios that we have here, if we solve for t in the first case, we have that t equals Fg plus Fc. In the second case, we have that it is equal to Fc minus Fg. Therefore, we know that case 1 must be our maximum scenario. And that allows us to now set up an equality between the two tensions that were given based on the information that we have. So we said that for the horizontal case, T must be equal to mv squared over r everywhere. In the second case, our maximum tension is mg plus mv squared over r. And this first quantity for the horizontal case is multiplied by 1.15 for the 15% greater. I'll mark that this is horizontal and this is our vertical case. So now we can begin solving for our problem by simplifying and then plugging in the quantities that we know. All right, so we can cross out our m's to get that 1.15 v squared over r equals g plus v squared over r. Now we want to solve for g in this case. And when we simplify, we find that 1.15 v squared over r minus v squared over r must be equal to g, which means that 0.15 v squared over r equals g. And now we solve. We have with our final equation for v, g times r over 0.15. Now g is of course 9.8 meters per second squared. That's just the acceleration of gravity. And our radius, which we're given in the problem description, is 1.1 meters. And that is going to be divided by 0.15, a constant, which is going to give us that v is equal to 8.48 meters per second, which is going to be our final answer to this problem.